Today we're going to take notes over chapter 2, which is all about matter and change. So to begin with, we need to define what exactly is matter. Matter is anything that has mass and takes up space. So objects that have greater mass, that means they contain more matter. Now, one type of matter is considered to be a pure substance, and then the other type would be a mixture, and we'll get to mixtures in a minute. But a pure substance is matter that is uniform and definite in composition. Which means it contains only one kind of matter. Now that substance could be an element, it could be a compound, but there's just one type of stuff in it. And all pure substances are going to have physical and chemical properties, and we're going to look at physical properties first. A physical property is a quality or condition of a substance that can be observed or measured without changing the substance's composition. Okay, so let's think about some examples of physical properties. Things that you can observe about something that's not going to change what it is. So a good example of that would be color. A substance's color is a physical property of that substance. Another example would be melting point. Solubility, meaning whether it can dissolve in water or not. Okay, there are lots of others. Odor, hardness, density, boiling point, if something is magnetic or not. All of those things would be considered physical properties. Now, these physical properties can also be called intensive properties, and an intensive property does not depend on the amount of matter present. So any physical property would be considered an intensive property. For example, if you have water, water has a specific boiling point. No matter if you have a cup of water or a bathtub full of water or a lake full of water, it is always going to boil at the same temperature. So intensive properties would be physical properties. Any of the ones that we mentioned above. Now, an extensive property does depend on how much matter there is. So that's going to be something like volume, mass. Those are going to be extensive properties, things that actually depend on how much of that sample of matter that you happen to have. Okay, now the three states of matter, obviously solid, liquid, and gas, those are actually considered physical properties. Okay, so whether or not something is a solid, liquid, or gas at room temperature would be considered one of its physical properties. A physical change is a change in matter that does not alter the chemical composition of the substance. Physical changes are going to be things that you can do to a substance that doesn't change what the substance is. For example, melting. If you melt gold, it's still gold. It didn't change what the substance is. Another example is if you dissolve something. If you dissolve sugar in your Kool-Aid, it's still sugar and you can get the sugar back. That's another way you can tell if something is a physical change, is if you can get the substance back to the way it was before. So if, for example, you melt a piece of ice, you could freeze it again. If you dissolve salt, you can evaporate the water and get the salt back the way it was. All right, now when we talk about a mixture, we're not talking about a pure substance anymore. Mixtures are going to be physical blends of two or more substances. Now, examples of mixtures could be any sort of thing. It could be something very simple like a salad. A salad is a mixture of lettuce and cheese and tomatoes and whatever else you happen to put in it. It could be something like air. Air is a mixture of a bunch of different gases. It could be something as simple as salt water is considered a mixture. All right, now there are two types of mixtures that we're going to look at. The first is a heterogeneous mixture. A heterogeneous mixture is not uniform in composition. So what that means is if you were to take samples of that mixture, that not every sample would be exactly the same. For example, when you're eating a salad, that would be a heterogeneous mixture. Every bite is a little bit different, so it's not uniform in composition. Whereas a homogeneous mixture is completely uniform in composition. So every sample you take is going to be exactly the same. For example, when you make Kool-Aid and you stir it all up, all the different things, every time you take a drink, it all tastes the same. That means it's a homogeneous mixture. Now in chemistry, homogeneous mixtures are called solutions. And solutions can be solids, liquids, gases. There are lots of different ways that you can have a solution. So for example, air is considered to be a solution of gases, and it's a homogeneous mixture. Vinegar is actually a mixture of water and acetic acid. Soda. Okay, it's a mixture of carbonated water and different flavorings and sugars. So those are all considered to be solutions. Now, in a mixture, you can have phases, and phases are basically the parts of that mixture. Okay, so when you look at a mixture, how many parts can you see? Homogeneous mixtures have one phase, meaning the mixture all looks exactly the same. You can't see more than one individual part. They're all evenly distributed and you can't tell them apart. Heterogeneous mixtures have many phases. When you mix oil with water, you can see the difference between the oil and water. That would be considered two phases. And a mixture can be separated into its components using the physical properties of those components. All right, so here an example would be if you had salt water. If you were to boil the water, okay, then the salt would be left behind. That's using the physical property that water boils at a different temperature than salt does. Okay, now, since we've talked about pure substances can either be elements or compounds, and we want to look at how we distinguish between the two of those, and we're going to do that in the next video.